Okay, we're going to do section 6J, writing equations. A couple things we need to talk about to make sure that we all know we're all on the same page here is independent variable. That is going to be your x value, the input, this is the information being manipulated. So this is being changed by an outside force. We're changing up by figuring out different heights. We're changing the temperature to see what that does to sales. So the change is the independent variable is being manipulated by a force on the outside, okay? The dependent variable is the opposite. It is our y value. It is our output. It is the information responding. Okay? So let's talk about, we're going to do a couple of these, and we're going to talk about different types. So we're going to do some real life examples here. Some of them are going to make sense, and some are going to be real life math examples that you're like, that wouldn't happen in real life. No, it wouldn't. This is a mathematical example. So we're going to talk about the difference sometimes. So let's talk about pizza, because I love pizza. Real pizza, not this stuff you dip in honey. Pizza costs $4 per slice. So we're going to talk about a couple things with this problem. We're going to graph this problem, and we're going to discuss how this works, okay? So let's talk about what is our independent variable. Which thing are we going to manipulate? What are we going to change? What do we have the power to change? We have the power to change how many slices of pizza we decide to eat or buy, okay? So the independent variable here is the number of slices. So that's going to be our x value. And we're going to graph, so that's going to be important. Our dependent then is what changes as we change the independent. It's what's responding to our changing. So as we change the number of slices, as we decide on how many slices, what does that change? That changes how much the cost is going to be. If we only have one slice, the cost is only $4. If we have 10 slices, the cost is going to be much higher. So that's going to be the y value. So I just talked you through a couple of them, but let's make a table, okay? I'm going to do a little different. I'm going to do a vertical table. I'm going to do the x and the y, but in the middle, I'm going to put the operation, the work, okay? And there's a reason I'm doing that, because we eventually need to get down to an equation, okay? So let's say I buy one piece of pizza. Well, one piece of pizza times $4, that's going to cost me $4. Okay? So maybe up here you want to not just put x and y. Maybe you want to put number of slices, and over here for the y you want to write cost, if that helps you understand better. Okay, so what if I need 2 pieces of pizza? Okay, that's $8. Well, that's all well and good. I could keep counting 3 pieces, and you probably figured out if we just add 4 each time, we're going to get our answer. But what happens if I just want to skip? And I say, well, I know I have friends with me. I want to buy 10 pieces. Then what happens? Well, it's still 10 pieces times $4, and that's going to be $40. So that could continue, right? We could continue doing that up to 100 pieces. But we want, again, this is mathematicians saying, you know what, I'm not going to sit here and write a table over and over again. I need some way to represent this, so I don't have to keep doing this over and over again. So they say, well, what if I don't know how many pieces I want, but I want a formula so that I can always get the right answer. Well, what's varying? And let's look at the work. What changes each time and what stays the same? In each case, this number changes. How many pieces we want. So that's where we're going to put our variable. What stays the same every time? What's our constant? The constant is the pizza cost $4. So that didn't change at all. So how could we write? We would say, well, y is going to equal $4 times x. Now notice I switched the x and the 4. The reason I did that, this is the accepted way of writing it, okay? So that's going to be our formula. So a lot of times mathematicians, they're like, I need to figure out a formula so I don't have to sit here and count pizzas or slices. I want to make it easy. So now let's do a graph of this. Now this is where real life and math life kind of don't always meet great. Oh, I wish I had. Let's see. I wonder if I can change the view on this in the middle. Yeah, I need to put some grid lines on here. Okay, perfect. Now I can see how much I'm off. Okay, so we're going to do a graph. So let's do our graph. And we need to make a well-constructed graph. The way I know I've done a well-constructed graph, I don't need to hear the story. I don't need to read the words. I just need to look at the graph. If it's a well-constructed graph, I know exactly what's going on without having to go back and read the word problem. So in this case, I'm going to call this a pizza party. That tells me, oh, I don't cross those. Yes, I do. That tells me we're dealing with pizza. Now I need to talk about my x and y. Well, we've already decided that slices of pizza is our independent. It's what we can change. This is what we have control over. That's our x. Over here is going to be the cost. So already I know, well, we're dealing in a pizza party. Somebody's getting slices of pizza. We're going to see how much it costs. I really have a good idea what's going on. And what you have to be careful of is when you're making your scale, make it make sense, okay? I'm going to go up to 10 pieces here. So when I'm doing this, I'm going to do it, I see people do this all the time where they write every single number. It's really hard to read that, okay? So I don't ever write every single number. I might put tick marks so I know you're counting. I might not, okay? Oh, I erased my line too. I got to fix that. Hold on. All right, so I'm going to count. I'm going to skip. I'm going to go half slices. So half slice, 1, half slice, 2, half slice, 3, half slice, 4, half slice, 5. Notice I'm not writing in all the numbers. Half slice 6, half slice 7, half slice 8, half slice 9, half slice 10. Okay? The reader can then ascertain what you're counting by looking at your numbers that you have on there. Okay? Now the cost, if I'm going up to 10 pizzas, I can go back up and I can say, well, that's got to get me to $40. So I have to be able to get up to $40. So let's see what I'm going to count by. I think I'm counting by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 40. Oh, no. I can count by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, no, I can't. I have to count by 2s. So I shouldn't have written those in. And this is kind of, you got to do some thinking through these. 2, 4, 6, 8, 10. Oops, let me put a 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, I'm halfway there. 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Okay, notice how I did that. I kind of went through and I marked. I had to figure out what I was going to count by. So now I'm going to put some dots on there. For one piece of pizza, it's $4. 2, 4. For 2 slices of pizza, it's $8. For 3 slices of pizza, it's $12. For 4 slices of pizza, $16. For 5, oops, let me follow the line up, $20. And you notice I can keep going. Now here's the question. In real life, do we connect the dots? Think about what this is talking about. This is talking about slices of pizza. Could I buy half a slice? Yes, I could. So then I could put little dots in between here, right? But if I connect them, that means I could buy any size piece of pizza I want. I could buy a slice of pizza that's 1/16 of a slice. That doesn't happen in real life. So though we may connect this in a math problem, in real life, we don't. This is called discrete data. It's not connected. Because in real life, we cannot buy 1/16 of a piece of pizza. I've never met a pizza parlor place. What about 1/32? Oh no, I want 1/100th of a piece of pizza. There's no way we would connect that. Now, if we did connect the dots, that would be called continuous data. And we will be working with that a lot. And that's where the dots are connected, okay? It's a line. So though this has a linear relationship, which means it looks like a line, it is not a line. It is discrete data. It's pieces of data that look like a line, that are following a linear progression, but they're not a line. Oh, I don't want to do all this. Okay, let's go to another example at our pizza party, but something has changed. Okay, I think I was doing, did I do 1 or A here? I do this all the time. 1, okay. So let's do our second problem of the day. We're only going to do 2 today for now. Let's say our pizza, we're at our pizza party again, but this is a little bit different pizza party. Somebody wants to make some money. So the pizza still costs $4 a slice. That's not a dollar sign. But there is an entrance fee to get in. I don't know, maybe they're using that to cover soda. I don't know. So the entrance fee is $3. So things have changed now a little bit. We're going to do the same thing we did before. We're going to talk about it. I don't know that I'm going to do a graph because you should know how to do a graph, but let's talk about how to take this word problem and make it into an equation that works every time so that the mathematician doesn't have to use a table every time. But let's start with the table. Again, I'm going to have work in the middle, so I'm going to put my x is going to be the number of slices of pizza, right? Because that's what I can change. And my y is going to be my cost. How much does this cost for this party I'm going to? And here's the work. Okay, well, let's say you come to this party and you don't like pizza, but you still want to go to the party. So how many slices of pizza did you get? Right, you didn't buy any. You got 0. So let's talk about that. What does that look like? Well, that means how much did it cost me to get in? Well, it cost me $3 total. What does that work look like? I don't know. Let's go to one piece of pizza and see if that helps us. So let's say I do want a piece of pizza. So that's going to be $4 for one slice of pizza, but I need to add the $3. Does the $3 change with the number of slices of pizza? Like, do you pay more money if you buy more pizza? Or is it a flat fee that you just pay one time? If it's a flat fee, then we just add it on the end. So in the end, we're going to add $3 to that. So we bought one piece of pizza, that was $4. I had to pay $3 to get in, so I better have $7 in my wallet. Okay, what if I wanted 2 slices of pizza? All right, well, that's 4 times 2 slices. So to pay $8 for the pizza, plus I need the $3 entrance fee, so it's $11. Okay, well, let's see if we can write the work now for 0. Well, I didn't want any pizza, so 4 times 0 is 0, but I still had to pay the $3 to get in. Okay. Now, of course, we're going to see a pattern. Oh, you're adding 4. 3 plus 4 is 7. 7 plus 4 is 11. But again, mathematician wants to know, well, I just want to skip up to 10. I don't want to do every single problem. That's a whole lot of problems to do. I just want to know if I go and I eat 10 pieces of pizza because I'm really hungry tonight, how much money I better have in my wallet. All right. Well, it's $4 for a slice of pizza, but I want 10 pieces. So that's $40. But I have to pay to get in. But I only have to pay once to get in. So that's plus 3. So that means I better have $43 with me. And so a mathematician then says, okay, well, I don't want to write a table anymore. I want to know, no matter how many slices of pizza, I want a formula to figure this out every single time. So I want to know, I don't know how many slices I want. It depends on when I get there, okay? What's our constant? What's the thing that's not changing every time? Well, the 3 is never changing. That's our constant. The 4 never changes, and we call that the coefficient because that's what it's multiplying by something. Well, in this case, what are we multiplying by? I don't know, because this mathematician doesn't know how much he wants to eat. So I'm just going to put an x in there. So what is my formula for cost? My formula for cost is y equals 4x plus 3. Well, how could we write that as a function? We could write that as f of x equals 4x plus 3. Well, that's a mathematical function. You could also write it, let's see if I can do this right, as cost is your function of slices of pizza. And that's going to be 4 times slices plus 3. So that's like the more real life way of writing that function. Cost is a function of the number of slices of pizza you eat. So tonight for homework, you're going to try some of this on your own.